Here some common acids. What is Ka? Ka is an example of an equilibrium constant, and in this case it measures the strength of an acid. So basically, the larger the Ka, the stronger the acid. In this video I will show you the Ka and properties for 15 common acids, their chemical formula, their melting and boiling points, and their danger rating from 1 to 10. Enjoy! Fluoroantimonic acid is the strongest acid known by mankind. It is made by homogeneously combining a 1-to-1 ratio of hydrofluoric acid and antimony pentafluoride. Why is it so strong? Fluorine is the most electronegative element in the table. Antimony hexafluoride is an antimony atom bonded to 5 fluorine atoms, and the electronegativity difference is huge. Thus, the antimony atom in antimony pentafluoride is really positively charged, and that's why it's strong. Oxalic acid is a very toxic strong diprotic acid, actually found in spinach, sorrel, and rhubarb leaves, but at lower concentrations. There's a dicarboxylic acid, since the structure consists of 2 COOH groups bonded together by the carbon atoms. There are 4 oxygen atoms in oxalic acid, so that it has a total of 4 in the structures, which greatly stabilize the molecules, thus accounting for its acidity. Sulfuric acid is listed as king of chemicals in industry. That is because it possesses the intrinsic ability to produce a huge motley of different chemicals, usually acting as a catalyst in each situation. It is divided and manufactured ethylene glycol, cleave carbon bonds, generate ethanol, and countless other compounds. Without sulfuric acid, all those chemicals that we take for granted won't be there. Known as oil of vitriol in the olden days, its first industrial scale manufacturing commenced in 1831, when the genius named Peregrine created the contact process. Nitric acid. In terms of toxicity, nitric acid is much more dangerous than sulfuric acid. Try to dissolve some copper in it and you'll see why, as brown fumes of its acid anhydride and nitrogen dioxide spills out from the reaction. This toxic gas is extremely deadly to living organisms, forming nitric and nitrous acid on contact with moisture. In terms of acidity, however, it is nothing compared to sulfuric acid. Nevertheless, it is extremely corrosive and should be taken with caution. Hydrochloric acid mixed with nitric acid forms a potent mixture called ochre regia. Now let me entertain you with the halogen acid's properties before we go on. Chlorine is an electronegative halogen, really from the extra electron to form a stable octet. As a bond of hydrogen, it sometimes heterolytically breaks the bond, leaving a proton or chloride ion. Even before it dissociates, the hydrogen atom is positively polarized, and this phenomenon is called the inductive effect. Like hydrogen and chlorine, the acidity of other halogen acids are completely based upon the inductive effect. Hydrobromic acid is one step higher than hydrochloric acid. Of the formula HBr, it consists of a hydrogen atom bonded to a bromine atom. As I have described, hydrobromic acid is so stronger than hydrochloric acid and is used along with hydrogen iodine in the cleavage ethers, which requires quite intense acidic conditions. Other than that, hydrogen bromine is also used in substitution of alkanes or in industrial reactions to form unsaturated products and stuff. Hydroiodic acid is the strongest of all halogen acids, and also the most interesting. This particular acid has some extremely clear properties. Aged samples of this acid may appear brown, though the pure acid is clear. This is because hydroiodic acid is quite unstable, and is oxidized even by oxygen. Hydroiodic acid is a good reducing agent, which contradicts the fact that it is a powerful acid. When reacted with excess iodine, it forms the compound Hi3. When left in the air, it gives its hydrogen atom to oxygen to form elemental iodine and water. Hydrofluoric acid is a very dangerous acid, and also has the highest boiling point of all of them, 19.5 degrees Celsius. Also, it is the least acidic of all the halogen acids, and since the smaller atomic radius means that it forms stronger bonds with the hydrogen atom. Hydrofluoric acid is respected for a well-known property, its ability to dissolve glass and certain types of plastic such as Teflon. Acetic acid is the main component of vinegar, and it has a vinegar-like odor. It is the most typical example of a carboxylic acid. Organic acid contains the 1 or COOH function groups. They are manufactured industrially by oxidation of aldehydes and alcohols, or by fermentation from bacteria. Acetic acid is completely non-toxic, so it is used as acidity regulators of various foods, with the code E260. Not only does acetic acid have a place in food, its compounds are also very useful. Phosphoric acid is a relatively weak mineral acid, despite the electron withdrawing positively polarized phosphorus atom in the center and the numerous possible resonance structures. It is relatively non-toxic. The concentrated acid may cause mild burns of the skin. The triprotic acid, with the ability to donate free protons to form a base from the phosphate ion. Phosphoric acid forms a wide variety of salts. Calcium phosphate, CF8PO42, is the main component of bones and teeth. Also, due to the number of carbonic acid is formed as acid anhydride, carbon dioxide is dissolved into water. As you can see, carbonic acid is another strange acid. The COH carbon atom is covalently bonded to another OH group. Thus, it forms 3 ordinary structures and is a diprotic acid. Carbonic acid is extremely unstable and decomposes into carbon dioxide and water by heating or shaking. This is why soft drinks fizz. As you drink it, the carbonic acid dissolved inside decomposes in your mouth. Carbonic acid forms 2 salts, the carbonates and the bicarbonates, or the hydrogen carbonates, being the polyprotic acid. Limestone is an excellent example of calcium carbonate. Hydrocyanic acid has been known as prussic acid in the olden days. A color is an extremely poisonous liquid. Hydrocyanic acid must be handled with care, though it's only a weak acid. With a boiling point of only 26 degrees Celsius, this acid is extremely volatile. The odor of hydrocyanic acid smells somewhat like almonds. Don't the hell with. Hydrocyanic acid denatures your proteins. To be precise, it forms coordination compounds of the iron cofactor of proteins. Phenol is also known as carbolic acid and is a weak aromatic acid, a benzene derivative. Benzene is an aromatic hydrocarbon with delocalized pi bonds at equivalent resonance structures, thus the kind of find stability. When the OH group is touched with benzene ring, its acidity is greatly increased since the loss of protein will increase the resonance of the ring and thus the stability. Though phenol is a weak acid, exposure causes pretty severe burns to the body. Ingesting damages the nervous system, and in serious cases cause seizures and coma! In the past, formic acid was prepared by distillation of dead ants. This is since formic acid is a substance present in the bite and stays in many insects, such as bees, wasps, and especially ants. Formic acid is the simplest carboxylic acid, containing a COOH group and only one other hydrogen atom. It is used as a preservative and a disinfectant, mainly to kill E. coli bacteria. Other uses including the tanning of leather and the coagulation of rubber. Formic acid is relatively non-toxic, so that it may be used as a food additive, which is E236. Hydrochloric acid is a volatile, unstable, toxic, explosive liquid with the chemical formula HN3 and an unbearable odor. Looking at the acid's properties, one can deduce that it is completely useless, but not its salts. One such compound, sodium azide, is used in the airbags of cars. When a shock is applied, a catalyst causes decomposition of the compound in sodium and oxygen, and such saving the driver's life. Other being an explosive, preservative, and a biocide, hydrochloric acid and its salts have no other use. Usually, heavy metal salts are used as explosives. Thank you!